Welcome back, Science 20s. So, when we were last talking about a voltaic cell, we were just finished talking about how, again, oxidation always occurs with anode, vowel, vowel. Reduction always occurs with cathode, consonant, consonant. Goofy rule number one. Goofy rule number two. Cathodes are always positive. Cats are fuzzy. They make Mr. Kemp smile. It puts him in a positive mood. Anodes are negative. Ants show up at the picnic, steal my picnic basket. That pisses me off. I made a lot really good sandwiches. That puts me in a negative mood. Goofy rule number three. If electricity is very, very smart. It always flows alphabetically from anode all the way over to cathode, A to C. Well, we're now talking about how in a salt bridge, you can put anything in here as long as it's got a charge on it, as long as it will conduct electricity. And so in this example, we actually put salt, table salt, NaCl. So I have Na positive and Cl minus. Well, let's take a look at this. And I'd like to point out another goofy rule number 4. Cations always flow towards the cathode. So in this example, I'm going to get my pen again. We know that positively charged things are called cations, and negatively charged ions are called anions. So in this internal circuit where I'm connecting this so I can have a continuous flow of electricity, right? Because I need a complete circuit for it to work. My cations are always, and I'm just going to darken this, they're going to flow towards the cathode. Goofy rule number 4, cations flow towards the cathode, which means anions, the negatively charged ones, they always flow towards the anode. So, goofy rule number 4, cations flow towards the cathode, anions flow towards the anode. Actually, quite easy to remember. Now, I said there's 5 goofy rules, and that is because when these ions flow towards the cathode, what we're going to notice is if we were to wait and watch over time, this electrode, this cathode, would actually start to get bigger. If you look at the half reaction, the Cu2 positive ions that are floating around in here, they're going to come out of solution. And notice, they go from Cu2 positive ions into Cu solid. They come out of solution and they make this electrode bigger. So I always like to say to my class, can anybody think of a cathode, a cat, a famous cat? And most people always go, Garfield's a famous cat. Okay, well, Garfield's favorite food is lasagna, and he would eat lots and lots and lots and lots of lasagna if he could, and he would get fatter and fatter and fatter if he could. Well, that's what happens to the cathode, the cat. Over time, cathodes always get bigger. Goofy rule number 5. Now, if the cathode always gets bigger, that means over here, the anode is actually going to get smaller over time or get eaten away. And if we look at the half reaction, this should make sense. Zinc solid goes to, so my zinc solid, my metal, will become ions. So this is breaking down into the solution, and I'm getting my solid actually eaten away. Now, in a real battery, this happens all the time. If you have ever left, let's say, your favorite toy and you put it away and you haven't pulled it out for a few years, and now you pull it out and you go to play it and it doesn't work. So the first thing you do is you check the batteries. So you open it up and in where the batteries are, there's all this white powder and stuff. And you're like, what happened? Well, in a typical battery, if you peel off what says Duracell and Energizer and the plastic, the metal casing, that's the anode. And what happens is sometimes the anode doesn't get eaten away, right? Because it gets smaller. It doesn't get eaten away evenly. And sometimes there's a weak spot and it eats a hole through. And then all those chemicals inside the battery seeps out of that hole into your favorite toy. And all that acid and all those chemicals wreck your little mechanism. And your toy that you loved when you were a child no longer works because all those acids and chemicals wreck the electronics. So if you have a favorite toy, please, please, please take the batteries out of it. I say this even to my students over the summer holidays. Your graphing calculator, it's worth a lot of money. Pop the batteries out so that those batteries are always working a little bit, and you don't want it to eat a little hole through the anode, and then you have to buy a brand new graphing calculator. So, goofy rule number 5, cathode gets bigger like Garfield eating lasagna, anode gets smaller, gets eaten away. Now, what I want to do is I want to look at this same example, copper and zinc, and rather than write you a big paragraph that says, let's take a piece of copper, put it into a copper solution, let's take a piece of zinc, put it into a zinc solution, now let's add wires and a voltmeter and a salt bridge filled with, we can give it to you this way. This is called cell notation, and this is the easiest way to tell you what the question is asking us to build. Now, there's some tricks to cell notation on how to read it. The first trick is everything on the outside of cell notation. So these two solids, copper solid and zinc solid, on the outside, those are my electrodes. So one of those is my cathode, one of those is my anode. The second trick to cell notation is everything inside from the electrode. So it's an electrode inside. These are my solutions. So I have zinc solution, zinc sulfate, and I have copper 2 solution, copper 2 sulfate. Now you'll notice we have some lines here. A single line means in contact with. So this line over here also means in contact with. Now, this is important because we read cell notation from the outside in. So copper electrode is in contact with copper 2 solution. Zinc electrode is in contact with zinc solution. And if you remember, on like the third page of this lesson, copper is in copper solution, zinc is in zinc solution. They have to be in their same half reactions. So a single line means in contact with. A double line means separated by. And in our case, we are talking a salt bridge. So copper solution is separated by a salt bridge with zinc solution. So if we go back and we look at this picture from the previous page, right, we have copper electrode in contact with copper solution, zinc electrode in contact with zinc solution, and they are separated by a salt bridge. So I want to be able to take this and show you how we can solve this if the question only gives you cell notation. So again, the trick to doing this is find all 4 of these substances on your reduction half reaction table. So there is one substance, there is copper solid, there is zinc ion, there is zinc solid. Again, we're going to start in the top left corner and we're going to go down, and this is my strongest oxidizing agent. So we're going to write this equation from left to right. And we know Cu2 positive plus 2 electrons. So as I write it from left to right, this is a reduction half reaction. So if the copper is my reduction half reaction, we know reduction starts with a consonant, which means copper is going to be my cathode. Consonant, consonant. Cathodes have the word cat in it. Cats are fuzzy, which means copper is going to be my positive electron. Now, let's look over here. Again, we're going down bottom right-hand corner, and I don't have the corner, so I'm going to write SRA here. Here is my strongest reducing agent, which means I'm going to copy my equation from right to left. So when I copy from right to left, zinc goes to Zn2 plus 2. Hey, I'm losing electrons. This is oxidation. Because it's oxidation, I also know zinc is my anode, because remember, vowel, vowel. Anodes steal my picnic basket. That pisses Mr. Kemp off. So he's going to remember then that that's my negative electrode. So zinc is negative anode because it occurs where oxidation is. Cathode is positive because of cats. That's where reduction is. So when I read this way, strongest oxidizing agent, this is reduction. I'm going to start down here and come up. When I read the other way, this is oxidation. The other thing we can do on this is remember, electricity is smart. Electricity flows this way, always from anode to cathode, because electricity flows alphabetically. So I know this is how I read this, because remember, the only way this works is if this reaction is spontaneous. Because when I use a battery, I want a battery to work. It's got to be spontaneous. So what I would like us to do is let's do an example on your own. So I am giving you this example. Pause the video, copy it down, and I want you to get as far as you can doing this example. So I'm going to go before I run out of time again. And in my chart, it says I have copper electrode in copper 2. So I'm going to find that. There's copper 2. There's copper solid. I also have silver electrode in silver. So there's silver electric ions and there's silver. So my strongest oxidizing agent is Ag positive, and my strongest reducing agent is Cu solid. So I am going to write this reaction going this way. And so I'm just going to throw my stuff in right now. So I have 1/2 reaction. Here it is, Ag solid. My solution is going to be Ag positive, and I'm going to copy my half reaction from left to right. So this is Ag positive plus an electron goes to Ag solid. Gaining electrons, this is going to be reduction. Well, since I know this is reduction, constant, this has to be the cathode. And cathodes are always positive. Let's do the other side. We were putting copper into this example, and they were going into copper 2 plus ions. So I found it here. We're going to copy this reaction going back the other way. So this is going to be Cu solid goes to Cu2 positive plus 2 electrons. Because we're going the opposite way, that is called oxidation. We're losing electrons. Electrons are on the right-hand side. Oxidation starts with a vowel, so this is going to be my anode, vowel, vowel. And since it's an anode and I'm anti-something or ants take my sandwiches, it's going to be negative. So 2 goofy little rules. Vowel, vowel, consonant, consonant. Rule 1, anode negative, cathode positive, rule 2. Now, electricity is smart, so we always go alphabetically, the electrons from anode to cathode, so that's another mark. Now, in my salt bridge, they told me it's going to be potassium nitrate. So I'm going to put potassium ions in here and nitrate ions in here. And remember goofy rule number 4, cation ions positively charged always go towards the cathode. Nitrate negatively charged always go towards the anode. Goofy rule number 4. We have one rule left, and our last rule is over time, the cathode is going to get bigger. So let's draw this guy getting bigger, like Garfield the cat gets fatter. And over time, my anode gets eaten away. So let's draw it getting eaten away. It's going to get smaller over time. If we go to mark this, I will give you a mark for the half reaction and for calling it reduction, for the half reaction and calling it oxidation. I will give you a mark for labeling your electrode as cathode and positive, your other electrode as copper, anode, and negative. You'll get a mark for your solutions, copper 2 in copper, silver in silver. So you'll get a mark for your solutions. You'll get a mark for showing me the directions of the electrons. You'll get a mark for showing me the directions of the ions, cations to cathode, anions to anode. And you'll get a half mark each for showing me which electrode gets bigger and which electrode gets smaller. Thank you for watching.